5. The same process, we divided by sine both sides, sine theta, to cancel. So r is equal to 5 times 1 over sine theta. Since sine theta is equal to 1 over cos secant, then our r will be r is equal to 5 cos secant. Now, we will convert polar equation to rectangular equation. For example, r sin theta is equal to 7 and r cos theta is equal to 3. r sin theta, we need to substitute r sin theta into 1 because y is equal to r sin theta. So, this is going to be y is equal to 7. r cos theta is equal to x, r cos theta. So, we need to substitute r cos theta into x. So, x is equal to 3. Okay, for the second example, r is equals to 5. So, we need to square both sides. r squared plus 5 is equals to 5 squared. So, we need, what is the square root of 5? 25. So, r squared. So, we need to substitute the r squared. X squared plus y squared is equals to r squared, right? So, we need to substitute r squared into x squared plus y squared. So, the answer is x squared plus y squared is equal to 25. Hello everybody, my name is Princess Gwen Magazine and let's talk about the types of polar equation. So the first type of polar equation is what we call Limacon. So Limacon or the Limacon of Pascal. So it is defined as a roulette formed by the path of a coin fixed to a circle when that circle rolls around the outside of a circle of equal ranges. So when we see this kind of graph, so this is what you call a Limacon. So it can be in this side, and downward. But when we see this type of graph, this is what you call a cargoid. So cargoid is a type of Limacon, but the A is equal to B. So the next type of polar equation is what we call rose curve. So when we say rose curve, it is usually a smooth curve. It is a curve that are loops that form from our resembled petals. So the number of petals will depend on the value of n, and the value of A is the length of the petal. So it can be like this, depend on the number of n.
Today we will tackle about another type of graph of polar equation. So we have the lemniscate, where it has a shape of an 8 figure or an infinity, like just like this and this. So the general equation of lemniscate is r squared is equal to a squared cosine 2 theta, and r squared is equal to a squared sine 2 theta, where a is not equal to 0. So that is the lemniscate. So let's proceed to another type of polar equation, the Archimedean spiral, where r is equal to a theta. Note that the graph of the spiral turns 0 and theta crossing the y-axis. So this is called Archimedean spiral, just like this, and it is based on the mathematician Archimedes. So I hope you understand that. That's all for today. Thank you.
Another type of graph of polar equation is a that the graph is extending as A increases. So like this. And so the formula using is R cos E to the power of 0.50. Another graph is when your A decreases, so your graph is compressed. So when your A is negative, so you will turn to the right, to the left. So as you can see that this graph is compressing because of the A decreases. And the formula using is R equals negative E to the power of 0.50.
So my third topic for today is about polar equations in circles. So polar equations in circles are graph of equations in two circle forms. So these are the four types of polar equations in circles. The first type is R equals to 4 cosine theta. So if you graph that form, it is a positive form. So you can graph it in the right side of the equation. So this our main origin is in the 2. And then we can graph it from origin into 4. So this is R equals to 4 cosine theta. And the second one is R negative 4 cosine theta. So since it is negative, you can put it in the left side of the graph. So we can put here the negative 2 and we can break our circle. Straight. From 4 to 2. It should be aligned with 2 in the lower side and 2 in the upper side. So you can create this 2. Third is R equals to 4 sine theta. Since it is sine, you can put it in positive at the upper side, right? So 4, we graph it in 2 here. So this will be our origin, our center of the circle. Then we can put start a circle which is aligned in the 2 and the other 2, which is 4. So this is R for sine theta. And the last is R equals to negative 4 sine theta. Since it is negative, we can put it in the lower side of the graph. So we can put our center in negative 2. And then we can create our circle. It should be aligned with the 2 in the side. So it should be equal with 4 sides. So this is. And this is R negative 4 sine theta. So these are the 4 types of polar equations in circles. There are many types of polar equations in circles, but I discussed only these 4 main types of polar equations in circles. That's all for today.
Good day, everyone. Today we are going to talk about polar equation and graph polar equation and coordinates. So, polar equation is any equation that describes a relation between r and theta. So, as we all know, r is the radius. Where r represents the distance from the pole to a point on the curve, and theta represents the counterclockwise angle made by a point on the curve, and the positive x-axis.
side by cos theta to cancel. So R is equal to 4 times 1 over cos theta. So since second theta is equal to 1 over cos theta, our R will be R is equal to 4 second theta. Example is Y is equal to 5. We substitute Y into R sine theta is equal to 5. The same process, we divided by sine both sides, sine theta, to cancel. So R is equal to 5 times 1 over sine theta. Since sine theta is equal to 1 over cos second, then our R will be R is equal to 5 cos second. Now, we will convert polar equation to rectangular equation. For example, R sine theta is equal to 7 and R cos theta is equal to 3. R sine theta, we need to substitute R sine theta into 1 because Y is equal to R sine theta. So, this is going to be Y is equal to 7. R cos theta is equal to X. R cos theta. So, we need to substitute R cos theta into X. So, X is equals to 3. Okay, for the second example, R is equals to 5. So, we need to square both sides. R squared plus 5 is equals to 5 squared. So we need, what is the square root of 5? 25. So R squared. So we need to substitute the R squared. X squared plus Y squared is equals to R squared, right? So we need to substitute R squared into X squared plus Y squared. So the answer is X squared plus Y squared is equals to 25. Hello everybody, my name is Princess Gwen Magazine and let's talk about the types of polar equation. So the first type of polar equation is what we call Limacon. So Limacon or the Limacon of Pascal. So it is defined as a roulette formed by the path of a coin fixed to a circle when that circle rolls around the outside of a circle of equal ranges. So when we see this kind of graph, so this is what you call a Limacon. So it can be in this side, and downward. But when we see this type of graph, this is what you call a cardioid. So cardioid is a type of Limacon, but the A is equal to B. So the next type of polar equation is what we call rose curve. So when we say rose curve, it is usually a smooth curve. It is a curve that are loops that form from our resembled petals. So the number of petals will depend on the value of M, and the value of A is the length of the petal. So it can be like this, depend on the number of M.
Today we will tackle about another type of graph of polar equation. So we have the lemniscate, where it has a shape of an 8 figure or an infinity, like just like this and this. So the general equation of lemniscate is r squared is equal to a squared cosine 2 theta, and r squared is equal to a squared sine 2 theta. where A is not equal to 0. So that is the limit case. So let's proceed to another type of polar equation, the Archimedean spiral, where R is equal to A theta. Note that the graph of the spiral turns 0 and theta crossing the y-axis. So this is called Archimedean spiral, just like this. And it is based on the mathematician Archimedes. So I hope you understand that. That's all for today. Thank you.
Another type of graph of polar equation is equiangular spiral, or known as logarithmic spiral. It has a polar equation of r equals e to the power of theta. The spiral extends as a increases and compresses as a decreases. The graph of the equiangular spiral crosses the y-axis as the sign of a changes. So now let's graph. If your a is positive, you will turn to the right. And it's stated here that the graph is extending as a increases. So like this. And so the formula using is r equals e to the power of 0.50. Another graph is when your a decreases, so your graph is compressed. So when your a is negative, so you will turn to the right, to the left. So, as you can see, that this graph is compressing because of the a decreases. And the formula using is r equals negative e to the power of 0.50.
So my third topic for today is about polar equations in circles. So polar equations in circles are graph of equations into circle forms. So these are the four types of polar equations in circles. The first type is r equals to 4 cosine theta. So if you graph that form, it is a positive form. So you can graph it in the right side of the equation. So this our main origin is in the 2. And then we can graph it from origin into 4. So this is r equals to 4 cosine theta. And the second one is r negative 4 cosine theta. So since it is negative, you can put it in the left side of the graph. So we can put here the negative 2 and we can break our circle. Straight. From 4 to 2. It should be aligned with 2 in the lower side and 2 in the upper side. So you can create this 2. Third is r equals to 4 sine theta. So since it is sine, you can put it in positive at the upper side, right? So 4, we got it in 2 here. So this will be our origin, our center of the circle. Then we can put start a circle which is aligned in the 2 and the other 2, which is 4. So this is r for sine theta. And the last is r equals to negative 4 sine theta. Since it is negative, we can put it in the lower side of the graph. So we can put our center in negative 2. And then we can create our circle. It should be aligned with the 2 in the side. So it should be equal with 4 sides. So this is. And this is r negative 4 sine theta. So these are the 4 types of polar equations in circles. There are many types of polar equations in circles, but I discussed only these 4 main types of polar equations in circles. That's all.